So those are a lot of the patterns from the POSA series that appear in Android and Java. I'd also like to just briefly touch upon some of the Gang of Four patterns that are covered, because you're probably more familiar with them, is my guess, if you've taken the CS 251 course here at Vanderbilt. So this again is from the classic Gang of Four book. And here's just a couple examples of Gang of Four patterns that are used. And these include the template method pattern, the strategy pattern, and the factory method pattern. And of course, there's other patterns that are used too, but these are some of the classic ones. So if you recall template method, which hopefully is at least somewhat familiar to you from taking CS 251, this is a Gang of Four pattern that provides a skeleton of an algorithm in a method, and it defers some of the steps in the algorithm to subclasses. And this is just a classic way. It's used in almost every imaginable framework to be able to decouple the interface from variants to the implementation. And this particular pattern shows itself quite dramatically in something called the handler thread class, which is something we'll describe in the context of the Android looper. And handler threads are going to have their own thread of control, and they're going to use the template method pattern in order to be able to have this hook method called onLooperPrepared that gets called back to initialize the handler thread when it's about to start running. Another classic Gang of Four pattern, probably my favorite Gang of Four pattern of all time, is the so-called strategy pattern. And this pattern is used to define a family of algorithms, to encapsulate each of the algorithms, and then make it possible to plug and play or interchange these algorithms so that clients and algorithms can vary independently. And again, hopefully you're at least a little familiar with this pattern. It's a really amazing pattern that shows up all over the place in class libraries, in frameworks, in almost everything you can imagine, middleware, platforms, user interface environments, and so on and so forth. And this pattern is used very heavily in the Android async task framework in order to be able to plug in different kinds of execution engines, whether they be single-threaded or multi-threaded and so on. They can be plugged in as strategies by using our good old Executor framework and the different mechanisms that the Executor framework provides. So they make it really easy to be able to plug and play these different concurrency models within the context of the async task framework. I should also point out, by the way, that the async task framework also is heavily involved with the template method pattern as well, although we may or may not see that depending on how much time we have to cover that particular pattern. Probably the most common pattern from the Gang of Four book that's used all over the place in concurrency environments and just in general is the factory method pattern. And this is a pattern that's used to provide an interface for creating an object, but leaving the decision about what particular subtype or concrete type of object to make to later, either by subclassing or by passing a parameter to the factory method to dictate what implementation is being requested. Again, by far, probably the most common Gang of Four pattern because it's used all over the place. And as we'll see, this gets used in interesting ways, such as thread factories, where you're going to be able to defer the choice of what kind of thread is created, either the name or the priority or the style, be it daemon or non-daemon, until late in the design cycle. And you can go ahead and use subclassing and overriding of factory methods to dictate the appropriate choice of semantics for these different kinds of threads. Java concurrency mechanisms, of course, are also very heavily used at the core of Android's concurrency frameworks. So there's lots of use of things like the linked blocking queue or blocking queues. There's lots of use of things like reentrant locks and condition objects, and even semaphore appears in a few places, although it's not the most popular pattern in Android because you don't really need its behaviors most of the time. But there's plenty of examples where Android concurrency frameworks and Android apps, for that matter, that are concurrent apps, use a lot of stuff out of Java, which is no particular surprise. And we'll discuss the patterns that relate to these things as we go through the lessons having to do with patterns for concurrent Android and Java programming.